Cool. Well, I guess I'll start. Hi, everyone. Good afternoon. Welcome. My name is Grasmeder, or Emma Grasmeder sometimes. I'm the ThoughtWorks Germany data witch. And yeah, my background is started out in, I have a religion degree, but I went to grad school to study experimental economics, where I learned a lot of statistics and game theory and data analysis skills. And then when I dropped out, I went on to become a data scientist, which I've been doing for the last several years. So that's a little bit about me. This is my colleague, Jin.
Hi, I work as a senior consultant at ThoughtWorks. So I've been doing several software projects, but in my personal time, I'm doing more projects focusing on machine learning and AI. And previously, I have industry experience in banking. Yeah.
Cool. So we're going to talk a moment about, we have to do the talking about ThoughtWorks for like 2 seconds. So just ThoughtWorks Germany has 250 people. We are consultants and technologists. We help people if you need to break your silos down and create a data lake, or if we need to help train people in agile methodology or do test-driven development. We love that stuff. And so we help people do that. And we also very much care about keeping things out in the open. So ThoughtWorkers are people who write books. ThoughtWorkers are people who push the industry for better standards or for better practices. And so that's why what we're talking about today has been, we've made it an open source resource that we'll show you the link for in a second. But yeah, so we're trying to, basically we're here to teach people how to get started on their very first data science project. We're going to talk about a problem statement, and then we're going to explore the entire machine learning pipeline that we've set up. It's a pretty basic, simple story, but this is an experience for people who have sort of no experience doing machine learning, no experience putting something into production that's machine learning at all. And yeah, so do you want to go over the agenda point by point, or? Cool.
Okay, so the problem that we want to solve is demand forecasting. So we want to predict item sales for a supermarket in Ecuador. So to get a better sense of problem, let me introduce the data. So we have trained data of some items' daily sales for 4.5 years. And then we have 4,000 different items, and it involves 50 different stores. And there are 125 million different transaction data, metadata. So our goal is to predict how many of each product will be purchased in each store on each day of next 2 weeks. So let's think about let's think how to approach our problem of demand forecasting. Of predicting item sales for a supermarket. So there are so we want to apply machine learning to solve this problem. So there are about 3 types of machine learning. Do you know what they are? Yeah, I already hear the answers. Yeah, great. Yeah, so there are supervised learning, unsupervised learning, and reinforcement learning. So what is supervised learning about? Mm-hmm. Yeah. Yeah. Mm-hmm. Right. Yeah, so in supervised learning, we have a target, which can be value or class, and we want to predict this target based on input. So it's about finding functional approximation, mapping input to output, and unsupervised learning. And it's on the contrary, it doesn't have a target. We have unlabeled data, and then we want to group data into similar ones. So it's more about finding compact data description. And reinforcement learning is very different. We only have objective, and then there are specific rules describing the environment, and then we want to find the best strategy to optimize the objective, and it's like a game playing. You play many games, and then you want to find the best strategy. So let's come back to our problem. So which approach is applicable to our problem? Yes, correct. Yeah. So our problem is relevant to supervised learning, and in supervised learning, it's about finding function, mapping from input to output. But then, what should be output in our problem? Yeah. So the future sales number of item in a store, on a specific day, and then what should be the input? So actually, it's going to be the focus of our main session. So we are going to do data exploration and feature engineering to find a better representation of X.
So it's time to get started. We made this as a GitHub repository, so if you want to, we recommend, go to GitHub and go ahead and clone this repository, ThoughtWorks Inc. /TWDE Data Lab. And so what we're doing is, if you install and then run this first file, you will download several different data sets from an S3 bucket, and then denormalize them and smush them all together and create we call it pretty dumbly, we call it the big table, which has all of the data that we might consider in this session. So go ahead and start doing this now. We're also going to come around and pass around thumb drives if people just want the data or the repository, if the internet's not working. So we're going to leave this slide up. I'm going to put the mic down, and we're going to make sure that everybody goes through this and can run merger.py on their computers right now. And so just get our attention somehow if you're having trouble with that.
Should I?
Thumb drives are going around. People already have some. So if you need one, just raise your hand, and hopefully we can get some. The thumb drives have the repository and the end data that comes out as a result of running Python merger.py, but it doesn't have the requirements. Like if you need the required packages to actually run merger.py, those requirements you actually need to download from the Wi-Fi that we have. And So we're going to explain what merger.py is doing, but basically it's taking several different data sources, like different tables that have been isolated, just like you would basically set up an SQL Wait, go ahead.
When you finish with the slides, give them back so we can pass them on.
Or share them to other people, Merger.py is denormalizing the data to make it ready to consume in a machine learning algorithm. Is there nothing we can do to... We had a question about the requirements.txt. You don't need the specific versions that are mentioned there. That was, I think, what was current when we made the repository. But if you have those packages in another version, it should probably work. Mostly what we're going to do today is Jupyter Notebook and Pandas data exploration. Is anybody having trouble with something?
You can also connect to PyData 2, which is just like phones. I don't know how you give it a try.
You're going to download a lot of data.
How much time do you give?
I'll say this out loud. So usually at this part of the presentation, we make sure that every single person in the room is able to run the entire data science pipeline on their machine. I don't know how scalable that will be, or how well it's scaled to this. Yeah, so how many people are ready to run Jupyter Notebook on their machines right now? That's a decent amount. So if you can't do that, because this is like mostly going to be y'all working. So if you can't do that, can you find somebody who is like, moving around to find a pair will be fun. But is it possible to find a pair? Can we put people who absolutely can't get Jupyter Notebook running to find somebody who can? That would require actually standing up and talking with people. This is like a thing that... This is how this is going to work. People are going to get next to each other and talk to each other and brainstorm about things. That's like an integral part of the data science process.
Let's have a show of hands who doesn't have Jupyter Notebook.
Who doesn't have Jupyter Notebook and won't be able to do data exploration on their own machines? Raise your hand high. This isn't a shame thing. This is like a, man, I can't do this yet. It's because my computer's not letting me. Okay, can people, keep your hands up if you cannot do Jupyter Notebook on your machine. Like, it's, yeah. If you've never done it before, then you probably can't, like, you don't have it. Can somebody invite these people who don't have Jupyter Notebook yet over to them so that they can pair with you? So who wants this person right here? Okay, we got a pair. You didn't have one.
No, I have
you,
Jupyter Notebook, but I don't have all that yet.
but we can get you the data. Who else needs Jupyter Notebook or somebody with Jupyter Notebook? I know there's more. Are there any people who still have thumb drives that are available? Can we get that one down here? There's a free thumb drive over here.
So we are going to proceed. I hope people find someone for whom things are working. So that was the data, subset data, because it's a data of stores in Quito area. Yeah.
Cool. So, so if you need the data, keep like raising your hand or looking around, and if you have a thumb drive that's free, like raise your hand up and we'll come and give it to the people who need it. So, cool. To explain the machine learning pipeline, cool. This is kind of the layout that we set up. This is exactly the layout that we set up for our machine learning pipeline. And each of these, like the green things are artifacts, and the blue things are actions that we're taking, and these are, we actually have different Python files for each of these blue squares in the chart. But so basically this merger.py, which I don't think anybody would be able to get to work, what it does is it goes to S3 and it downloads different tables which have different specific pieces of information. And it merges them. It basically does a left outer join on a certain column. So we could use the date, for example. If we had a whole bunch of data, actually we can go to the next slide and talk about that. So what merger.py is going to do is it's going to take your like some data that we were given from the client, from the grocery store, and it's going to take some external piece of data set. For example, the price of oil for this during the time period that we're talking about, or the consumer price index for the time period that we're talking about. And it's going to add that new piece of data, like the consumer price index, on the table that we already have, so that every data point that we have given a certain date will be merged onto this one agglomerate giant data table that's being developed, which we called big table. So this is a process of denormalization, and the reason that we do this is because this bottom table with like all of its sort of weird redundancies, like if we were going to be like good database administrators, we could probably extract out this like redundancy of the state and the city and the cluster, and like there's a bunch of repeated information in this. It's a very inefficient way of storing data, but this is the way that machine learning algorithms like to consume their data for the most part. So that's why we're doing this. That's why we're smushing them all together.
And so these are the data from the these are the information from the raw data, but we might consider designing more features. because the data is like time series data, but then we want to represent. We want to design data to fit the supervised learning.
Cool. So the next step in that flow chart is to split the data. And the reason that we do that is because we want to have some way to prevent overfitting our data and making sure that we are making our predictions in an unbiased way, that we're not getting stuck in some weird local optima and preventing ourselves from thinking that we're doing a great job when we might actually, once we get more data, we might find that our model only works for the time frame that we're talking about, or that we've already seen. So the way that overfitting works is when you try to make a model, one of the simplest models that you could think of as a linear regression, or maybe a polynomial regression that's a little bit more complex. But these linear and polynomial regressions create a model that tries to map out the data. And a linear regression, on this first tab, you can see it doesn't describe the data very well. It's never going to be exactly where, or it has like an infinitesimally small chance of being right about any particular data point, but it doesn't even, to the human eye, you can see that this doesn't describe the data correctly. If we skip the second one and come over to the third, this model is describing the data that we have perfectly. Every single point we've accounted for, and it's just like a perfect representation of the data that we already have, but it's a terrible representation of the data in general, because if we were to imagine if we got another point, say like we got another data point further along the x-axis, what's the likelihood of this jaggy line actually representing the next data point that comes? It's not showing a trend, it's just mapping to the data perfectly. And the next data point is likely going to follow the trend, but we can't imagine, like the behavior outside of the time frame of this model is undefined. That's why this model in the middle is a really good representation of the data. If we were to get another data point someplace, we would still be describing, like it would fit into the model pretty well as it has been so far. So yes, we haven't actually touched any of these points. We haven't predicted anything perfectly, but we're predicting it generically in a very good way. So the point of splitting the data is to be used in a validation strategy so that we can actually make sure that we haven't overfit our data. And then the next step in this data science pipeline is to actually train your model. And the reason that I included this is how much code, if you've never done it before, this is how much Python code it takes to actually do machine learning. You just throw some data, you throw one data frame in, you throw another data frame in, bam, you have a model. Now you can ask it a question, it'll give you an answer. It takes 10 lines of code to do machine learning, but that's not the hard part. So there are ways that we can tweak the data, or we can tweak the algorithm. There are important choices about choosing an algorithm, but a lot of this can be made independent of how you prepare the data and can be made as an ongoing iterative process. And so the reason that we don't focus on that in this presentation, we're focusing on the more sciencey part of actually exploring the data and understanding what information to give to the machine learning algorithm. And even if when we've chosen the right data to give to the machine learning algorithm, we can swap out algorithms and try something new, or we can try to parameterize our algorithm differently. But the work that we've done choosing and preparing the data correctly is going to be useful regardless, most likely. So here's it again. Start out with a lot of different data sets, plug it in to, join them together with the merger, and now we have this big table. The big table is the thing on the thumb drive that's coming around. So everybody now has big table on your computer someplace. You don't need the merger.py file if you already have this big table. Then we split it to make sure that we can assess the efficacy of our algorithm. We train the model, and then we look to see how well our predictions stand against the actual values. We could do a whole presentation about validation of data, of algorithms, but we're talking about data exploration and feature engineering today. So, do you want to talk about exploratory analysis, or should I?
I think you can go.
Cool, I'll keep going. So, the purpose of exploratory analysis is to understand the data that you have, to ask questions about, like, what do these anomalies mean? What does this actual value that looks pretty normal mean? And then to also be able to communicate your findings with your stakeholders or your colleagues or yourself in the future, to squeeze out more information, to give your algorithm a little bit of a hint. And yeah, basically to know about the next, or to know what to do for the next step, which is feature engineering. This is part of, so this was, I was just doing some exploratory analysis, and this came from the data set that we're talking about. This is a graph of the median return rate. So what we're talking about is negative sales that happened in our like across the entire year of our data set. So there's obviously something different about, like there's something that stands out. Can anybody tell me what stands out about this data set? So the thing is January, December. So before I was able to do this, I had to ask the question, what is a negative sale? Like, what does that even mean? My data set says unit sales, and then there's like a bunch of negative numbers. So what the hell does that mean? It turns out if you've worked in sales, that might mean, like, you might know that that might mean things have been broken, things have been stolen, or things have been returned. Those are negative sales in the retail world. So when you look at this and you know that this is a graph of things that have been broken, stolen, or returned, we have this question of why is there this huge spike down in January, or just at the beginning of January or the end of December? So the answer is Christmas. This is like maybe right after Christmas. We could make a hypothesis that right after Christmas, people are returning gifts that they didn't want or whatever. Or maybe we don't have exactly the granularity to know if maybe this was people stealing things before Christmas or breaking things while they're fighting on Black Friday. We could ask that question, which of these things is happening, by looking at the data a little bit deeper. Do you want to talk about this one?
Yeah, so this is another interesting example that you might find in data exploration. So this is the graph of daily unit sales for a specific item and in a specific store of the year 2016 in October. So this is like unit sales of 1 month. And then looking at this graph, like what kind of hypothesis do you want to make?
Or what do you notice? Yeah, we have a hand. Yeah, so I think I heard on weekends we have higher sales. I can't maybe tell by, I don't know which day 0 is, but yeah, in any case, there's a cyclical.
Yeah. So like you might find some seasonality in terms of weekday. So you want to consider like a day of a week in your features. Yeah.
So the question is, what do we do when we know that there's like something obviously weird going on around Christmas? Or what do we do when we know that there's something obviously, like there's a cyclical pattern throughout the week? How do we tell our data science, our machine learning algorithm, hey, this is happening? Like, if we give it enough data points, eventually it might figure that cyclical pattern out. But there's ways to help the algorithm along. So that's what feature engineering is. That's where you can better represent your data by showing more features or different features to the algorithm. And this, you could also do things like reframe your time series data in a different way depending on what type of algorithm you're using. Yeah. Should we go to the next one?
So I want to add a little bit more.
Please do.
Okay, yeah. So actually this is interesting problem that when we think about how to reframe time series data for supervised learning, and what kind of strategy can you think of? There's a time series data, but then we want to represent we want to represent as one data point to predict, in order to predict future sales of a specific day for a specific item in a specific store. Yeah, I mean, so yeah, we can think about it more, and then I want to emphasize that if we make good features, it can already serve as baseline model. So baseline model means you don't actually have to use a complicated machine learning algorithm. So I mean, machine learning algorithm is often effective, but then sometimes we don't know what's going on inside. But then to have for our sanity check, it's nice to have like some baseline number that you can compare with the result of your machine learning algorithm, that your machine learning is actually doing enough work.
We have a question over there.
Could you please give an example how you would reframe time series into
Yeah. So it's in one of the following slides. We are getting there soon. Yeah. Thank you.
Cool. So yeah, what we're doing today is we're going to do data exploration with the goal in mind of someday adding features or changing features, changing the input that we give our machine learning algorithm. It's an iterative process, and this is why it's good to pair on things. Yeah, that's what's coming ahead. I don't know what else is on the slide. And the question of how do we do it with Jupyter Notebooks. We do it with pandas. You search for something on the internet like Pandas cheat sheet if you've never used it. If you've never used Pandas before, you don't know how to look at a specific column, you don't know how to compare columns. You also ask your neighbor, because somebody in here probably knows the answer to whatever thing you're trying to do. And we don't need to do that because that definitely won't work. But so ignore the wget part and just go and bring up Jupyter Notebook. The way that I do it on my MacBook is I type in Jupyter space Notebook, and it'll bring up a new browser tab or a new browser. So go ahead and ignore the first step, but do the other two things right now. So probably in Terminal, probably wherever you have downloaded Jupyter Notebook. And remember, nobody raised their hand when they didn't have Jupyter Notebook, so I know everyone has it. Bring up Jupyter Notebook and create a new Python. It doesn't have to be Python 3. Create a new Python notebook, and we can start looking at the data. Is anybody wanting one of those pairs right now? Does anybody want somebody who's more familiar with Jupyter Notebook? We can try to pair you up together. Cool. Yeah. Mm-hmm. So are we ready to go? I guess if we didn't have to download anything.
We have a lot of time.
Yes, we have a lot of time, but we're going to give them the chance to come up with hypotheses together. Okay, I think we can go to the next slide, yeah.
Okay.
So wherever you've saved this big table that came off the thumb drive, you need to import pandas and do a read CSV with a local path pointing to wherever that data file was stored. So this part, yeah, you do import pandas as PD, then you'll save a data frame, which is equal to pd.readcsv, and then the local path to your big data.csv file. So go ahead and do this now, and this will be the first step, and then we can, yeah, break out into groups. Yes. This is downloading it. If you use the thumb drive, then you don't need to do that. So what we're doing here is we're opening up a brand new notebook and not an existing file, and we're going to, like, this isn't part of the, this is happening in parallel or aside from the pipeline that exists. So the splitter.py and things like that, those are useful when we're putting things into production, but this step is helping us know how to split and what to, and how to merge and how to, what to put into the machine learning algorithm, but not part of the actual production pipeline. So you'll open up a new file and then load the data yourself. A little bit, and like people don't raise their hands unless you're like standing really.
Oh.
So it seems like one of the thumb drives had some corrupt data. If anybody's getting an issue of parsing and like something on line 34, we can get you the right data. So who else needs the data again because the data was corrupted on theirs? We have 2 people over there. Anybody else need a thumb drive again? Okay, we need to get it to you and you. Anyone else? Up there. And there's a thumb drive over there. Can you pass it down to these 2 people or? Okay.
Or should we show this? I mean, yeah. So if you manage to load the data, like think about these example questions, and then of course make more questions in your mind, and try to explore the data, and even think about like which feature is going to be helpful to predict future sales.
And if you find the thumb drive that's got the bad data on it, get it. Let me know. Okay, so at this point, if you have the data on your machine and you've pulled it up into Jupyter Notebook, you might have typed in that last command that we had recommended, or something else that you found on the Pandas cheat sheet that looks interesting to you. Like maybe I always look at the head, I just like, what's the top of this data look like? What columns do we have? Maybe I type in PD or df.columns. And so I already got a question. The question was, what does day off mean? We have a column called day off. And this is exactly the process of data exploration. You look at the data, you find some things that don't make sense, you ask what it means, you do some research to answer that question. Sometimes research is asking somebody who knows the answer, or sometimes you have to go do a sociological study of Ecuador to figure out what exactly is going on there. So in this data set, we include something called days off. Do we also include the days off observed or the holidays observed? I don't remember. But so there's day of week, which maybe is what you are actually seeing. But we also might have holidays in there. And there's a difference between, in Ecuador, there's a difference between a holiday that's like, this is the official day according to the religion or according to the constitution or whatever, and this is the day when we actually don't have to go to work. So if there's like a holiday and holiday observed column, maybe we took it out, but that's what that would mean. So either you're looking at day of week, or there's something about, there's the actual holiday, and then there's the day when people don't have to work because of the holiday. That's an example. So what other questions do people have of this data as you look at it? Some of the types of questions that you might want to be asking are, for example, what is the actual time frame of this data? We told you, I think we said it was 4 years, but I don't know if that's actually true because we might be using a subset of the data. So what is, like, how many days are we actually looking at? Which item type is sold the most is another question that you could start out. Like, you're basically, we've planted you on a foreign, like another planet, and you have to go explore this planet and understand where the dangers are, where the confusing things are. You have to figure out if gravity still works. You have to figure out what are the parameters of this data. So some of the obvious questions, just like, what is the shape, like what does it look like if I just look at the distribution of sales, or of like looking at a specific store's sales? So we looked at the example of sales following a weekly cycle, and we looked at the seasonality effect of Christmas. So this is your time to get familiar a little bit with the data, and then I would like some questions from y'all about what questions do you have of the data, and what will you try to learn from the data today? Does anyone already have questions that they want to know of either of what the data means, like what does this column mean, or like something that they want to explore in the next 30 minutes or so? Yeah?
What does CPI mean? I've always been cost per item. I guess those for different items that you wouldn't expect in cost per item.
Sure. So the question was, what does CPI mean? And CPI is the economic measurement called the Consumer Price Index. This is, I think it's like the cost of a bundle of goods in 1970. It doesn't matter where it's set to, but it's basically how much does bread and milk and maybe a car, just like a bunch of consumer goods that might be representative of the expenses of the average person. And then as that goes up or down, like wages will go up and down, but it's kind of a measurement of real wage as compared to the nominal wage, which is just a number that, depending on inflation and other things, might mean different things. Any other questions? What other things do people want to know about the data set? Or either in like actual, hey, this is confusing, you set this up poorly questions, or questions that you want to know from a data science exploration process. Yeah? What is the class called There's a feature called cluster. Do you remember what that means? That was.
I think it's a category of I think the feature cluster in the big table is category of stores. So this giant supermarket chain, like they have several classes of stores, like a high class and like a middle class, maybe discount stores. So yeah.
So, and it's possible, because we wanted to make this doable for most people in a conference on their computers, that there's only one cluster represented. It might only be that one. But yeah, it's... Okay, so there's a day off, which is a Boolean. Okay, so the day off would be that it's officially a holiday where nobody is working. The day of the week, I don't remember if it starts at, it starts at what? But does it start on Monday or does it start on Sunday? That would be a question that you could probably figure out with the other columns. So, but yes, it means... Okay, yeah. But the day of week being a number means that like Monday is 0 and Sunday is 7, or maybe it's modulo +1. I don't remember. Yeah.
Yeah. How does one deal with non-numeric data, such as city name?
How does one deal with non-numeric data? Jin, do you want to talk about categorical data?
So it depends on machine learning. So for some machine learning, you have to convert non-numeric data to numeric data. So there are like two approaches that I can think of. So you can just like assign arbitrary numbers to categorical data. Or you can do, if you want to be more strict, you can do like one hard code encoding. So one hard code encoding is better because you're not giving arbitrary ordering to non-numeric data. But then it might get very big if you have many categories.
So you encode it to make it look like a number that represents the string that it. Yeah. So, other questions? We could make people present. That would be fun.
So, is there any person who might want to talk about their findings?
I mean, we don't have Yes.
Okay.
Was that a? Did somebody want to talk about something they found in the data? Maybe later.
Okay, then shall we talk about the next?
I don't know what the next slide is.
Yeah. So I want to give you like a little bit more hint. So what might be findings relevant to feature engineering? So you might have realized that there is different amount of data available for item store. And in the worst case, you might not have any data for a specific pair. And if you don't have data available, like what are you going to do? Like for the missing data, for example, if you don't have on promotion data, like what would be the value that you can fill up? So on promotion means literally it means the item was on promotion on the date. So if the data is not available, what would be the good default value? Yeah, this is Boolean.
So the question is, so we have this column that says, is the good, was it on promotion on the day that it was, on the day that we have data for? And sometimes it's yes, sometimes it's like no, but sometimes there's just no value, which doesn't necessarily mean it's not on sale. What do we do about that? I saw a hand up there. What did you want to say?
Yeah. We also agree that that is a reasonable default value, like on promotion as false, if it's not available.
But that's a huge assumption. That's,
yeah.
Another option is to just delete every row that we don't have data for a certain column.
Okay, yeah. So you can try like several things, like and then it can be iterative. You can come back and then try other approach. Yeah.
So that suggestion was to put some sort of weight or another column that says we don't know if this was on promotion, but we can make a guess. Did you have a?
Maybe we could assign true or false somewhat randomly and say, okay, we know that 10% of the time stuff is on promotion. We assign 10% true.
So that was to assign randomly or given some model based on the data that we already have.
Mm-hmm. Yeah, that might also work. And then if unit sales is not available, like what would you which value would you use?
So if there's missing data on the unit sales number, yeah. So hold on, I heard average, but this guy had his hands up first. So to imputate based on the mean value, but then the mean of what? Across the entire year? The mean of the sales across the entire year? Right, sure. So that would be a suggestion to do it without a weight on the present.
Yeah, actually, so we had experience of exploring the data, and then actually we used that approach for our baseline model. But then it turns out that default value unit sales as 0 turned out to be better. So it seems that the most of missing data was coming from small sale number items.
Yeah. And to do a mean across the entire data set is not necessarily a bad idea. It depends on the data. It depends on how actually predictive it is. Yeah.
What would be like an indicator which method is better to use, or is it just like try and see?
So the question was, are there hints in the data about which method you should use for dealing with missing data, I think.
So that's about validation. So yeah, for that purpose, we are splitting data into training data and validation data. Yeah. So, but sometimes it's tricky. Like to get ideally, we want to have validation data as similar as possible to test the data. But sometimes it might be difficult, especially for time series data. Like how do you know like this 2-week period is similar to the neighboring 2-week period? So yeah, that is challenging. Yeah. And then we want to talk about how to reframe time series data for supervised learning. So, do you have any ideas? So, yeah. Right. Yeah. Yeah. So consider that we want to predict Y is future sales, and then what we have available is historical data. So, like, what is good way to summarize historical data? Any ideas? Statistics?
Moving average?
Oh yeah. Who said that? Okay, great. Yeah, actually, I'm going to talk a little bit more about that. Yeah, and then we have a seasonality. So we want to consider like at least weekday pattern because like in data exploration we saw like a cycle in unit sales. So I want to talk about moving average a little bit more. So moving average, it might be a good feature to add, especially for reframing time series data to supervised learning. So like this is the example of showing like what moving average like implies. So we have this blue line which is raw data, very jiggly, and then you have green line, which is a 5-day moving average. So we are averaging for the last 5 days. And then you can see that green line is smoother than the raw data. But then if you look at 20-day moving average, then you can see it's even smoother than 5-day moving average. So you can consider it like roughly a short-term trend and long-term trend. And then you can include even more kinds of window size, and then you can include them in features. And then for weekday average, to reflect weekday patterns, you might also want to consider weekday average. And then if you have like this kind of if you design many kinds of features, then you might also consider what would be a good baseline prediction. So, like as I said, like for baseline prediction, like you don't have to apply machine learning algorithms. So you can already guess, like without any machine learning algorithm, what would be the best guess. So, do you want to try a little bit more, like in this direction? Maybe a little bit more, and then if they have questions, I mean,
So so now is some more time to ask questions of the data. Does anybody, I guess before we let you do that a little bit more, does anybody have more questions about what does this column mean, or what is this feature talking about in the data set? Cool. So then I would let y'all like talk amongst yourselves and try to ask questions of the data. Figure out if there's an interesting thing about produce items and seasonality or whatever, like sort of questions and hypotheses that you have about the data. go try to dig into that and talk to your neighbors and ask them questions about how to perform certain operations on data frames or whatever you need, and then we'll come back and talk about what your questions have been and what you've learned about the data in that time. So now is time for it to roam around throughout the data. And of course, if you have questions, just raise your hand and we can talk about them.
Okay. So I got a question how to get moving averages in this data. So actually I see like a couple of ways available. So you can convert date column to date data type, and then there's like NumPy, like there's like time delta to there's like time delta, and then you can just plus minus time delta to get to move the days. Or actually in the big data, in the big table, there's already in the second way there's already column called days until end of date. So that already shows like which the distance from the last date. So yeah, you can use that to filter the data for like moving average of a specific window size. So the problem is to predict the item sales of the following 2-week period from the last date of training data. So one data point that we want to predict is for specific item, specific store, and specific date. So the date is the following 2-week period after the train data. Yeah, date, yeah. So, yeah, if you like succeed getting various moving averages and then weekday average, then I mean, what would be good baseline prediction? You might want to give weight of weekday versus like the total mean, and then you. That multiplied by the median of like various moving averages, for example. So you can try several approaches. And then if you want to do evaluation, like how effective your approach is, then you'd better use metric. So this is like one metric that you can use, and so y-hat is prediction, and then plain y is a true value, and then this is how you measure the errors of your prediction, and then w is the weight, which is bigger for perishable items.
So this might be one of the things you could use to validate your hypothesis that we should put zeros for the. Like any missing data, we'll just make a 0 or a false, and then you could use this in their validation strategy to see if it makes the error term a lower number. So I have this in almost all of my slides that if you didn't know, there is an algorithm that can help you choose which algorithm you want to choose. So the scikit-learn documentation is beautiful, and you can read it like a textbook, which we all read textbooks like regular books, right? You can learn a lot of amazing things in the scikit-learn documentation and quite deeply understand how the algorithms work. But at first pass, if you're wondering which machine learning algorithm do I want to use in my data science pipeline, after I know how to join all the data together, I know how to use it, split the data for a good validation strategy. But that one part about using the machine learning algorithm, this is a decent place to start. And then you can get at least an MVP out there. You can swap in or swap out an algorithm if you choose, like, actually my data is a little bit more something, a little bit more that, like, appropriate. It's more appropriate for a certain different algorithm. You can choose later. But the important part is to get a deeper understanding of your data and to start putting your pipeline together and get something that's productionizable. And then we can worry about exactly which algorithm to go for later. So here it is again. This is the pipeline that we've proposed for you. Each of these could be, I guess you could have these each as an AWS Lambda. That's you could put it in a data science pipeline on AWS. And basically, yeah, so the part that we have been working on is nowhere on this graph, but it will definitely help you in your merging. If, say, we want to add a new thing, we think the CPI is a bad piece of data to use for some reason, and we really just only care about the price of cheese. So we can add a new table that just cares about the price of cheese in the world or something. If we want to add new data, we put it into this. Because of our data and because of our feature engineering and data exploration findings, we can put this new data set up at the top on our S3 bucket, and then we can modify our initial merging file to now consider this new table that we've added, and that will inform the rest of the pipeline, so that when we throw it into the training step, maybe we'll have a better output. So now we can talk, if you have questions either about the data or about the process or about putting things into pipelines. We have 7 minutes left for questions if people want to talk. Wow. Cool. Okay, a question. Yeah, so the question was about S3 buckets and what is that. So S3 is a service provided by Amazon that is just a storage service. It's basically, you can put files and store them relatively cheaply, but you don't have to use Amazon. All of the cloud providers are about at the, like, some of them have better one thing or another thing, but we're at the point where if you're using Google or if you're using Amazon or whatever you're using, it's probably going to be pretty good for whatever you're going for. S3 is just what I'm experienced with, and so I usually just throw all my data up there. And the way that pipeline would work, can we go back one slide? The way that it would work is you can store all the data, like store the training data on S3, download it so your algorithm will download it, and then store this new table in another place on S3. And then when you split it, you can, that could again put out a new artifact that's stored on S3, and this way you can kind of version your data. You can also upload your latest model that is created in the training section and store a new model. And so basically, if you get some weird output, you can know, like, so I used this version of the data and this version of the algorithm, and for some reason it gave me wonky results, or I'm predicting poorly, so you can kind of do a retrospective on what actually happened given those different versions. Whereas I think often when you just do it in a notebook, like in a Jupyter notebook or something, if something starts doing something new, you don't have a written down history of what was the data looking like at the time and what was the model looking like at the time.
How can you save the knowledge of the so you do one train, and then after 1 month you want to realize that you don't want to start from scratch. You want to save stuff from what you were wanting to. How do you do that?
So you can pickle models or you can export models from pandas And you can save that file wherever you want to and then load it up again. I think it's just like 2pickle, like data, like model.2pickle or something. Does anybody know the actual? It's ask Google, how do you pickle a model?
Or if it's not too big, you can use CSV or zip file. Yeah, if that works.
Other questions? Okay. So I guess we can show the thank you slide. Thank you. And